However, as we move to the cellular networks, and as we have more and more sophisticated cell phones, for example, iPhones, there are a lot of things you can do with your cell phone. Well, the cellular providers love this because this means that they can push a lot of functionalities into your cell phone, which means that the equipment at the network, at the base stations, can be simplified. Right, this is good news for the equipment manufacturers. But in terms of security, this is a big warning sign. Because once you cannot trust the cellular devices, you have to decide of everything that the device has told you, the network, what do you have to verify and how you can verify those information. Okay, so I have told you the vulnerabilities. Are these vulnerabilities real? In other words, can an attacker take advantage of these vulnerabilities to attack the network? I'm going to show you one particular attack. So the goal of this attack is to hoard as many time slots as possible by the malicious cell phone. So the cell phone could launch this attack for two different reasons. The first reason is being selfish. Okay? You want to get as many slots as possible. For example, if you are downloading the latest video, I mean the latest kernel of Linux. And this is the first reason. The second reason is that if you really want to disrupt a cellular network, then you want to shut off every other user from the system. Now, increasingly, cell phones are used for emergency response purposes. And there's a trend that the voice is being carried over through the data channel. If you can shut everyone off the data network, then chances are that in the future, they may not even be able to contact the emergency services like 911. So that will be a big problem. Regardless of their intentions, the attacker just wants to grab as many scheduling slots as possible. And we have devised a tiered attack. So the first tier is the first tier attack is called the intra-cell attack. So which means that the attacker stays in the cell. So this attack exploits the unverified channel condition report by cell phones. In order to increase the effectiveness of the attack, we designed a second tier attack, where this attack spans more than one cell. And this attack exploits the handoff procedure of cell phones. Okay, I'm going to tell you how each of the attacks work. But before I tell you attack, let me make my threat model explicit. So a threat model tells you what we consider as threats and what we do not consider as threats. So we assume that the attackers control a few cell phones, and these cell phones have been legitimately admitted into a network. For example, the attacker could have spread malware onto cell phones, so that the malware will execute according to the attacker's intention. And also, if the attackers doesn't have malware, then attackers can simply go out and buy some prepaid data cards. Okay, they are very popular. So cellular data, prepaid data cards are very popular in Asia and Europe, and I saw that they have already become available in major U.S. cities. Okay, so by this way, you can attack the network without being identified, because you pay cash for the prepaid card. And we also assume that the attackers can modify the cell phone, perhaps the software or even the firmware, to modify the way that cell phones report channel conditions and the way cell phones request the handoffs. However, we do not assume that the attackers can penetrate the cellular networks. Okay, so this attack was launched entirely from a cell phone. Okay, it does not penetrate the cellular network. So in our first attack, we assume that the attacker knows the channel condition of every other cell phone in the network. You might think that this is an unreasonable assumption. Yes, it is an unreasonable assumption, but I'm going to show you later how this assumption can be relaxed. Once the attacker knows the channel condition of all the other cell phones in the network, then his attack strategy becomes very simple. If you recall from the previous slide, the base station selects the cell. Can you see my mouse? Okay. The base station selects a cell phone to schedule, such that the scheduled cell phone has the maximum value, okay, the maximum ratio between its instantaneous rate, data rate and its average throughput. So therefore, the attacker simply calculates its instantaneous channel quality indicator such that its ratio is the maximum among all the cell phones, and then it reports that channel condition indicator to the base station, and the base station will schedule it. Very simple. And here's our simulation results. So we have a cell of 50 users, and we let between 1 to 5 of the users to be attackers. And we measured how many continuous time slots that the attackers can get using the attack strategy that I showed in the last slide. As you can see that if there's one attacker, the attacker can get 20 continuous time slots. Whereas if there are 5 attackers, then they may get about 100 time slots. But think about it. This is not really very impressive, because if you recall, a time slot in HSDPA is only 2 milliseconds. So 20 time slots is about 40 milliseconds. And even 100 time slots is about 200 milliseconds. Okay, that's less than a minute. Yes, the attackers can get this like less than a second all to itself. But this doesn't really affect other mobile devices a lot. Okay, there's a jitter, but that's it. So this attack cannot continue. So the next question is that how can we improve this attack? Is it possible to perpetuate this attack? And we discovered that, yes, you can do this. And here's how you do it. Remember that proportional fair guarantees fairness only within the single cell. In other words, within the single cell, once a cell phone gets scheduled, its average throughput will increase, but its ratio will decrease. The ratio between its instantaneous data rate and its average data throughput will decrease, which means that once a cell phone gets scheduled, it will have a lower scheduling priority in the future, at future time slots. However, proportional fair does not carry over across different cells. Once a cell phone hands over to a different cell, its average throughput is forgotten. Therefore, the cell phone can start over again with a very low throughput. And based on this observation, you can design the following scheme to attack the network perpetually. Suppose the attacker can have 2 cell phones, and can place the 2 cell phones in the overlapping area of 2 neighboring cells. And suppose the 2 cell phones can communicate with each other, for example, through a local area network or Wi-Fi. At the beginning of the attack, the top cell phone is admitted to the left cell, and the bottom cell phone is admitted to the right cell. And each of the 2 cell phones launches the attack that I showed you earlier. Okay, each of the cell phones tries to get as many scheduling slots as possible. So each of them can get about 20 continuous scheduling slots. Once one of them can't get any more